Ever since 1993, Gabe Navigator came out, web browser remains the default way of how people interact with internet and get information. From online shopping, reading, entertaining, and communication. And every year, this huge amount of new data and website has been created for many different purposes. There's an estimation that by end of 2024, there will be 147 zettabytes worth of data will be created. 1 zettabyte is equal to roughly 1 trillion gigabytes. That is huge amount of data. Just by Facebook itself, it estimates to produce more than 4,000 gigabytes of data every single day. Apart from this giant web platform, their new websites came out all the time. According to Forbes, there are 252,000 new websites created every day. That basically means 3 new websites are built every single second. So just for the past 60 seconds while you're watching this video, more than 100 new websites has been live. So we all know the amount of data and traffic growing on internet are growing really fast. But what you might not know, a great amount of those web traffic are actually not human behind a computer trying to browse the internet, but from bots and other computers trying to getting information out from different websites and internet. Since internet is filled with valuable information, those bots and computers search and extract best content out of it. A process we often refer to as scraping, which is a process where developers will write a script to mimic web browser and make simple HTTP requests for the URL to get information out. For example, I have this personal blog website called aijason.com, and this personal blog has no API endpoint for you to access all the blog information. To get information from my personal blog, I can just open the terminal and do curl with my website URL and click enter. Then this command line will automatically send a request to my website and get the website content back in the raw HTML format. And if you don't know what curl is, it is a protocol for transferring data with URLs. And I can also download data to local file by do curl website URL and create a file called aijason.html. And this will download HTML file into my local computer. If I open the folder, there's one web page. If I open it, basically download the whole website data. And on the other hand, apart from calling specific web page, there are a lot of web services that provide API endpoint for you to fetch internet data, like getting Google, Reddit data, or weather data. For example, I can do curl and call a specific weather API service, which will return me clean structured JSON data about a specific weather in a specific city. However, most of the websites and web services don't really offer such API access for people to use, because quite often those data are actually the assets the company owns, like news media, LinkedIn, or e-commerce websites. So they don't really want to provide API service for people to just grab data and build a new website. And on the other hand, most of the website's traffic is so low, like your personal blog, they just don't really have a need or budget to build an API service for people to use. That's why web scraping is the main way for developers to get structured information from all sorts of different websites. But the complexity here is that website builders are often designing the website for humans to consume, with lots of beautiful graphics, nice navigation and animation, which is great for user experience, but not really good for machine to get access to data. For example, to provide faster response time and better user experience, modern websites often don't load everything in the first request. They will do some techniques that only loads as you scroll into specific area. And quite often, information are actually gated behind a paywall that requires subscription or certain authentication. So you can't just do a simple HTTP request to get the content out. And there are all sorts of different interactions that have pop up to get people to do something before they can access content. And for obvious reasons, some websites have CAPTCHA to prevent those bot traffic. So to be able to scrape those websites, developers need to write script to actually simulate real human behavior. For example, wait for a few seconds before the information actually fully loaded to start getting the information, or can simulate the typing, clicking, scrolling behavior in the browser directly. And to achieve this, developers often use headless browser. And if you never heard about headless browser, it is basically a type of web browser that access web pages but don't have a real user interface. So you can almost think about Chrome, Firefox, those type of web browser that you already use but don't have any inputs for you to interact with browser. But all the interaction will be detailed by a script, which can simulate user interactions like typing, clicking, scrolling, downloading data, and all sorts of different things. So essentially, these browsers operate in the background and executing web page exactly like a standard browser would, but without displaying any content on the screen. This makes them useful for various automated web tasks like testing and web scraping. And popular browsers like Chrome, Firefox all have headless mode already. But directly operating and controlling those headless browsers is not as straightforward. You need to interact with the browser's dev tool But fortunately, there are libraries like Playwright, Puppeteer, and Selenium, which provide high-level API to control the web browser. So developers can write script a lot easier. You can just give very specific actions like create a new page, go to specific URL, fill in value for inputs, and those code can work across multiple different web browsers. So that you can basically write script to dealing with different type of complex web browser behavior, like progressive loading, authentication, clicking and typing behavior, and even captcha. But one caveat is, even though you can write script to simulate real user behavior, web scraping is still a really operation-heavy task. And the reason is that each website structure is widely different. The scraper you build for Airbnb won't really work for many other travel websites where you also want to get hotels or listing data. And there's literally no standard way to have a script that can work across all sorts of different websites. So to do proper scraping has been a really heavy automation work. In some companies like travel aggregator, they used to have a big amount engineer resource are spent on just creating and maintaining different web scrapers. But with the birth of large language model, a universal web scraper that can scrape in any type of websites on the internet is finally possible, because large language model enabled a few things that wasn't possible before. Firstly, large language model is extremely good at handling unstructured data. So a lot of people already have a use case where you feed large language model a big blog or 1-hour interview transcript to ask it extract key insights. And the same thing, we can just feed large language model any structure of DOM elements from the website and get extract specific JSON format. And regardless of the website structure, language model can just always looking at any website and extract the same JSON output. And this means developers don't need to build specific scripts to handling and parsing different website structure. All you need is just come up with good prompt and get large language model generating unified JSON data. And secondly, as the development of multimodal model like GPT-4v becomes better and better understanding visual elements, now is the first time that we can really align how machine and human browse and consume internet data. As I mentioned before, most of website builders, when they design a website, they are designed for human as a consumer. So there are a lot of animation and UX are great for human experience, but not necessarily good for machine to consume. Or platform that design great UX for human to use with complex UI component that is great for user experience, but a lot harder for the bot to interact. With the emerge of multimodal model like GPT-4v, those models show strong capability to understand the web page and interpret the actions to take to complete web tasks. In a paper published by Microsoft, where they tested all sorts of different visual tasks, and part of the test is web browsing and GUI navigation, where they will give GPT-4v different screenshots of computer and web browser and ask it to interpret what's the next action to take. And GPT-4v showcased capability of completing certain web tasks, like doing a Google search of specific recipe, browsing through multiple different blogs, and diving into specific web page that contain the full end-to-end, and in the end, extract unified information. So those multimodal large language model for the first time can really align how machine and human browse the internet data, which will probably lead to smaller gap between how human were manually scraping the information versus what the machine will return. And then multimodal ability combined with agentic behavior can enable some really powerful and advanced web browsing agents, where the agent can have direct control of a web browser and use a multimodal model to look at the screenshots or the DOM element and decide what's the next best action, and in the end simulate real user behavior like clicking, typing on the browser itself. And their platform like Multi-On or Hyperwrite already create personal assistant that can directly control your web browser to complete complex web tasks. So I personally think this opens up a huge opportunity for people to build a universal web scraper that is powered by agents. And this agent is almost like an API for the whole internet, where you can just give natural language to this agent about specific data point that you want to extract from internet. And this agent can just scraping whatever website or data source to get the information back. So for the past week, I've been exploring how can you build such a universal web scraping agent. And I want to share my learnings with you as well as specific case study of how can you build one as well. But before we dive in, as an AI builder who tries loads of different models and software on my MacBook, this MacBook I bought back 2021 started feeling really slow. Sometimes even laggy when I do normal browser tasks. So I almost about to buy a new MacBook. But thanks to Clean My Mac X, I didn't have to. If you are using Mac OS system and you haven't really used Clean My Mac yet, I definitely recommend. It is the most popular and easy to use Mac performance optimization. It has super clean UX, and my favorite feature is Smart Scan. Basically, you just click on one button and it will do the cleanup, malware removal, and speed up all in one combo. It takes about only 2 minutes to polish up even a that slow Mac. So boom, I just removed around 6 GB unneeded junks. On the other side, they also have this feature called Space Lens. It will give me a bird's eye view on my MacBook to see which files are taking a huge amount of storage, but I never use it. I can dig into each folder multiple level deep and see what type of files are taking a lot of storage that I can remove, or view and modify what applications will be run automatically when I open Mac. So Clean My Mac X can really turn my old MacBook into something that almost feels like a new Mac. So I definitely recommend go give it a try. You can click the link in the description below to try Clean My Mac X for free for 7 days. And they also offer 20% discount code exclusively for this YouTube channel subscribers. Now back to our web scraping agent. So at high level, there are 2 ways I explore to build such agentic web scraper. Method 1 is more API based, by calling different API service that can already give data back, but we use agentic behavior to scraping multiple different data source and return the information back. And second method is give the agent direct control of the web browser. Teach the agent how can they use web browser and get information back. For more complicated use case, where the website has complex pagination, infinite scrolling, captcha, or authentication. So for the first one, which is the API-based agentic scraper, the way it works is pretty straightforward. I basically want to build an agent that has access to different type of existing scrapers to get information from the website. And the agent can receive any type of research task, like getting all the listed renting properties in SF from specific website. And the agent can just start scraping those websites, getting the raw data, but utilize large language models capability to get structured information back. And we can utilize a lot of different marketplace and platforms that already offer a huge amount of data source, like Rapid API Marketplace, API-Fi, or even platform like exa.ai, where they basically embedding the whole internet data and allow you to do natural language and semantic search, which sometimes it can return more relevant information rather than Google. And the challenge of those type of agentic scraper I face with, one is the clean data. The data it returns is either raw DOM elements, which contains huge amount of noise that I don't really need, or just stripped out text, but a lot of information were removed during that process, like links, images, and files. So without clean data to start with, to build such agentic researcher is quite hard. Fortunately, there was one open source project came out a few weeks ago called Firecrow. They grew really fast and had more than 2.7 thousand stars on GitHub. And they basically provide an API endpoint that can turn any website into large language model ready markdown data. They remove all the noise but still keeps the links and website structure. And this made the amount of data that feed into the language model much more clean and relevant. So the performance is way better. And I'll show you how can you use this to build a really high performance web scraper. And the other challenge I faced with was planning and memory of the agent. So if your scraping and research task is pretty simple, like you just want to get the number of employee of a certain company, that task is normally fine. But quite often, the scraping needs a bit more complicated. The use case I know is users want to collect a list of different data points for a specific entity. Like for one company, they might want to know multiple information like number of employees, case studies, whether the product is live or not, the pricing, competitors, all those information from the website or internet. And through this process, it will require the agent go through many different websites and data sources. So how can we keep the agent to remember what information has been collected already? To be able to deliver the final results effectively is a big challenge. And one solution I tried that seemed to work pretty well is that having a scratch pad where the agent can read and write data into. Even though the agent is scraping through multiple different websites, whenever it found a specific information like number of employees or competitor or case study, it will just save that information to a database and then dynamically updating its system prompt and insert a short-term memory. And second method I explore is a browser control-based agentic scraper, which means we basically build an agent that have direct access to a web browser so that it can simulate more complex user behavior, like going through multiple pages in the pagination, handling capture, or even logging to go past authentications. And the way it works is that you will use common tool and library like Playwright or Puppeteer to set up browser session for the agent. And the agent can either look at a simplified DOM element, decide what's the next actions, and actually simulate those user interaction like typing, clicking, scrolling in the browser directly. Or it can even use multimodal model like GPT-4v to take a screenshot of the web page and do some pre-processing like a bounding box, feed that to GPT-4v to decide on next actions, and then simulate the user interactions. So those type of agents are really powerful when you build things right. It can go past almost any website since it's simulating the real user behavior. But this type of agent is also a lot more complex to build. I'll give you one example. If you're building an API-based agent, all they need to do is just call a function called send email, and the task is done. But if you're building a browser-based web agent, to complete such task of send an email, it needs to take so many different steps to even complete a simple task. From go visiting the gmail.com, clicking on the search bar, search for a specific email, click on the right email, click on reply button, typing out a response, and click send. So this type of agent does pose a much bigger challenge in terms of planning and memory. And on the other side, there are also a lot of complexities in terms of locating the right UI elements to interact with. Let's take web page as LinkedIn as an example. If you ask agent to sign in, there are literally 3 different sign-in buttons on the web page. Each one of them represents a different action. So sometimes it's quite difficult for agent to know which is the right UI element to choose. And if you're using DOM-based agents instead of vision-based agents, this task is even harder. For example, this is one of the video clips I showcased before in another video, where another web agent builder is talking about challenges they faced with in terms of locating the specific UI element.
This website has given me nightmares. The issues with the HTML encodings are just endless. Like for example, you see this like placeholder text in this input over here. It's actually not a placeholder. It's set dynamically by another element, not the search box, by another element that's somewhere else in the document tree. Yeah. So that means that when you go and you look at this actual element for the search box, you don't actually know what it is. So that prevents the language model from understanding where to input its search query.
But luckily, there are teams that have been working on libraries to make this task easier. One of the libraries that I started working really well is called AgentQL. They basically build a special model where you can give agent a specific UI element that you want to retrieve. Then the model will try to identify and return that specific UI element for the agent to interact with. So you can get the agent to interact with web UI element quite reliably across different websites using a library like this. And on the left is a quick demo of how you can build a scripper that's scraping through all the different Tesla websites to get information and save it somewhere. And same methods can even work on mobile UI as well. You can just give the model specific UI elements that you want to get, and it will automatically return you the right UI element on the screen. So I also built a universal kind of scraper for e-commerce website using AgentQL that can scraping through all sorts of different e-commerce websites. And the last part of the challenge is scale. So even though we can build some quite powerful web-based agent on your local machine to complete certain tasks, when you really want to put into business setup, you actually need to run at scale. And the libraries we're using here, like Playwright, Puppeteer, is actually not that lightweight. So running thousands of those different web sessions are actually not that easy. But there are also teams that have been working on this problem to enable you deploying headless web browser on the cloud very easily. So their team called BrowserBase, they basically allow you to run headless web browser at very large scale. So you can build a web-based agent that's serving thousands or millions of customers very easily, like Multi-On did here. So there are many super talented teams around the world are working on solving those individual problems that can really enable such a universal web scraper agent. And you can already build a few super powerful web agents. And I'm going to show you step by step how can you build those universal web scraper by yourself. So firstly, I want to build a universal agentic scraper where user can just give a list of companies as well as website, then give a list of different data points that they want to collect about each company. And the agent can just do the research and fill in all those empty cells. And I wanted the scraper to work in a very specific way where it can research as much as possible within that company domain, which means it can navigate to different pages in that specific company website. As we know, the data source there has higher quality. But if the agent can't find any specific information, then it can go to internet to search. To do that, I will open Visual Studio Code. And first, let's create a file called .env file. This is where we're gonna store all the credentials. In our specific case, we need a file crawl API as well as OpenAI API. And next, I will create a new file called app.py. In here, we'll firstly import a few different libraries and load the environment variable. Then we'll define OpenAI, and the GPT model we're gonna use is GPT-4 Turbo. And firstly, let's create a few functions that agent is gonna use. One is a script function, and I'm going to use the hosted file crawl service. They also have an open source version, so if you want to host by yourself, feel free to do. And it's pretty straightforward. I just define file crawl app, try to script the URL, and return only the markdown information. I will also create a function called search So this is another service that Filecore also have that allow you to search across the internet and return clean data. The agent going to use this search function if it can't find any information from the company domain websites. But I want to implement in a way that agent can always find whatever the data point that they found into a database and use that as an additional context to know what information has been scripted already. The search endpoint will clean up the data and return most relevant search results. So the content it return can be quite big. That's why for the search function, I actually have two parts. On one hand, it will call the API endpoint and return the search results. But on the second part, I will actually feed the research result into a large language model to do a summary to extract only most relevant information. So I will call the search API endpoint to return the results. Then I will try to get the data keys, which is a list of column name that user defined, and put together as a prompt that will feed a large language model, and run a chat completion to get the most relevant result back. So this search function should return us the most relevant information. And third, I will also add a function called update data. So this is a function that allows the agent to continuously read and write information to a database so that it can be aware about the information that you already found as well as data source that already visit. So this function will basically take some data points to update and save to the global state. These three are basically the main functionality the agent will need to have access to. And next, we will just need to create some function calling agent from scratch. So I will have some help function, one is chat completion request. Then I will have another function to log all the syncings and results from the agent. And I'll create a tool list. I will also create one function called memory optimize to solve one challenge where the large language model have limited context window so that it won't exceed the token context window limit. And I just did a pretty simple implementation here, where if there are more than 24 back and forth conversation or the number of token of the agent chat history is in 10,000, then I will just automatically take the last 12 different conversations, then do a summary of all the conversation. And this will be using the smaller model like GPT 3.5 Turbo and put together a new chat history. I have one help function called call agent step. We can basically decide whether we want agent to make a plan before it start action. So if plan is true, then we'll get agent to firstly think step by step, make a plan first, and then continue the conversation. But if not, we'll just get agent working directly without making a plan. And we will write a for loop to get agent to execute until large language model return the finished reason to be stopped. And we will run this memory optimization after every single step. And this is pretty much it. All we need to do now is just connecting everything together. As I mentioned before, I want this agent to follow a very specific procedure to do research as much as possible within the company domain. And if there's nothing can be found on their company domain, then go search the internet. That's why I break down the workflow into two stages. The step one will be run the agent to do website search, where the agent will have access to two functions. One is scraping, another is update data. Then the agent will start doing the research within the company website of the data point that is not known. Then the second stage will be internet search, where I will get a function of search as well as update data. Again, it will start doing research, but on the external internet source. Here I will link to the entity that we want to research, the links that we already script, as well as data points that we haven't found yet as an instruction. Now we can just start triggering this agent. I will create a global state called link script, data points that we want the agent to collect. In my specific case, I want to find a list of companies who are offering catering to the employees, and to understand the number of employees as well as office locations. So if I'm Uber Eats for business, I can know whether this is a good candidate company or not. And the entity name is Discord as well as a website. So I will run these two different stages. In the end, return the data points. So I can open this, then do Python app.py. So firstly, make a plan about which data source to research about. First, they script the Discord page, which it will return a bunch of subpages. Then next is start research about the career page, I believe, but didn't look like Discord official website provide any useful information. So it moved to the second stage of the internet search and start calling the search function. Now, this time it found some information about number of employee to be 750 from this data source, which I can click on. So this is from one of the website called Zapier. And then it just updates this data knowledge about number of employees and office locations. After that, it did a second search where it found that there's some catering information where Discord provides their employees with special perks like fund to investment in work setup, as well as online events like cooking class. And in the end, it returned back the data points, the catering offer for the employees, the number of employees, as well as office location. And each data point has a reference link to back up. So this is an example of how can you create a super smart universal scraper that can just go on internet as well as specific website it was given to find information. This works for some general website that doesn't have content gating or information that doesn't require complex UI interaction like pagination. But if you want to scrape, let's say, information from each e-commerce website where you want to apply specific search query and also need to work with pagination, then we will need agent to directly control the web browser. And this is a second type of agentic web scraper. And I'm going to use a library called AgentQL to set up a universal e-commerce website scraper. So what I want to achieve is an agent where I can give a URL and then it will be able to scraping through all the product information and also click on every single page in the pagination until all the information has been collected. To do this, I will first go to .en file, put in AgentQL API key here as well. Then I will create a new file called browser agent and then load a few different libraries. I will first define a query called products. So this is a query that will give AgentQL to return the information we want. And for each product, I want the product name, price, number, review, and ratings. And on the other side, I also want to get next page button. So this is the next button on the pagination. And here you will notice that I try to get two elements. One is next page button enable, another is next page button disable. The reason I want this two is because even though we reach the last page in the pagination, there will be still a next button, but it will be in disable state. So I can write a while loop to continuously go to next page until next page button disable is true. So that's pretty much it. We can firstly start a AgentQL session by doing agentql.startSession and give it a URL. And I can also control to scroll to the bottom because for some e-commerce website, the pagination will only be loaded after you scroll to the bottom. Then I will create a file called products.csv with mode to be append so that it keep adding new data to this file. And I will create 4 different columns: the product name, product price, number, review, and rating. And while the next page button enable is true and the next page button disable is none, I will try to run another AgentQL query to get a list of products. And for each product it returned, I will add to the CSV file. And in the end, I will click on the next page button. Again, scroll to the bottom and try to get the next page button again. And repeat this process until it reaches the last page. So that's pretty much it. Let's try it out. So I will open terminal and run Python browser agent.py. So you open the browser and automatically scroll to the end of the web page where the pagination will be loaded. And if I open the terminal on the right side, you will see that it gets the enable button to be go to next page is 2 and disable button is none. And it scripts the first page's product information, click on the next page, go to next page, and start scripting the second page product information. And also get the next page button to be go to page 3, so that it will repeat this process until it hits the last page. And once it finishes, all the product data will be saved to the CSV file. And if I open the CSV file, you can see that it automatically returns all the product information across multiple pages. And what's really cool about this is that this scraper not only worked for Amazon, but almost any e-commerce website. For example, I can go to eBay and just copy the eBay search results to the agent. And I can run exact same script again. And this time it will open the eBay, scroll to the bottom to get the pagination buttons. And if I open the terminal on the right side, you will see that it again gets the next page button and return that page's product information and fetch the next page button again. And it's going to repeat this process again and again until you get all the information that it needs. So this is another quick example of how can you create a browser-based agent as well that can script specific. So as you can see, there are a huge amount of possibilities for us to create a scraper now. I'm really interested to see what type of scraper you will be start creating. This is one area that I'm personally really passionate about. And I do plan to launch a universal agent scraper that can enable people to scrape any type of information on the internet. If you're interested in that universal agent scraper, I put a link in the description below so you can sign up. Once I finish that scraper agent, I will let you know. And please comment below for any question you have. Thank you, and I see you next time.